If you'd like to take a seat, we'll be starting very shortly. Can you save me a seat? You think she's joking, but she's not. Okay, hi there. Welcome to TechMeetUp. We're going to have two talks today, and we're going to do the introductions in between the two talks. So hopefully that will work well. We'll see. Just a few things before we start. You've probably seen the TechMeetUp website at some point in the past, but just in case you haven't, there it is. In just one moment. It's at techmeetup.co.uk. Couple of other things that we have now. We have a meetup group. Please do encourage all your friends, enemies, anyone really, to join it. Because that way we get some idea of how many people are coming. Although, according to today, we're getting 12, and I'm not great at counting, but that looks like more than 12, with no actual information with 1st of April. And finally, if anyone's looking for a job, the company I work for happens to be hiring. So if that's of interest and you're looking for a job, we're looking for translators, but we're also looking for coders and various other things. Come and talk to me later on, and I'll tell you a little bit about us. We're called QueryClick. Thanks very much to our sponsors, Skyscanner, Cultivate, and Informatics Ventures, and also to Codebase for providing the space here tonight. And I'll pass on to Alyssa, who's going to tell us about bugs in the Ruby interpreter.
If only I had 3 hands. Now we cross our fingers. And we try a different port. I mean, my slides are online, so we could just load them on Justin's laptop, and that would work. Yeah, yeah. Oh? Something's happening. Everything has gone absolutely tiny, and now I have 2 displays, and now I'm back to just 1. And now something else is happening, and everything's gone tiny again. Oh, right. Okay, let me see if I can adjust that. Yeah, I don't know why it's doing it at such a high resolution. There's a lower resolution. Let's not mirror displays. And right, okay, gather windows. Okay, let's try that. If you say so. No. Oh? We get signal. Main screen turn on. Go ahead. Yeah, I think. Do you want to? Yeah.
Of course, whether it'll work with it now.
Technology isn't it wonderful when it works? Because maintenance.
No, this one doesn't work. What did you change down here? Because it wasn't good.
I just bypassed.
I thought this went into the right box.
I just bypassed.
Well, bypassing doesn't seem to work.
Well, this one worked without bypassing. So could you undo whatever you did? You can use Edge or Firefox. I use Chrome for work, so you can't use that. That seems terrible. I think you're going to be better with Edge, which is the first time I think I've ever said those words.
No, you have said it when trying to fix cinema tickets at one point. No, that's just somewhere outside being function.
Do you think it's worth trying to get this to not mirror so I can get my speaker notes, or shall we just not bother with that and assume that it's going to break everything? We can. Yeah. No, we don't. It's not important. Slight spoiler in the URL. Haha. Okay. Hello, everybody. My name is Alyssa, and I work for a company called Free Agent, about 10 minutes away in Fountainbridge. And I'm going to tell you a story about something that happened to me at work about a month or two ago. And my job is looking after the tools that the other software engineers at Free Agent use. And this is sometimes internal tools that we write that are specific to our stuff. Sometimes it's external tools that are produced by the free software community. And sometimes it's a combination of the two of those and the intersection, and strange things that only happen when the two meet. So I got somebody coming to me on Slack, and this is what they said. I'm struggling to run our website on my computer. Middleman keeps crashing. With this error happened 6 times in the last 30 minutes. Does anyone know how to fix it? Thank you. And nobody knew how to fix it. And when nobody knows how to fix something like this, that means I have to know how to fix it. What I had to go on was this error from Ruby. You may have encountered a bug in the Ruby interpreter or extension libraries. That's fun. Now, people like to say that it's never a compiler bug. And there is a good reason that people say that. Because when you think that, oh, I just don't understand why this isn't working, and you're tempted to blame the compiler or the interpreter, 99% of the time, that's a problem with your code. Thank you. But sometimes, compilers and interpreters are programs just like any other, and sometimes you find that actually you have discovered a bug in the compiler or in the interpreter. But at this point, I didn't know that. This message says you may have encountered a bug. And this message is a bit misleading, and over my time working with Ruby, I have learned that this message doesn't actually mean that you may have encountered a bug. Or, well, you may have, but most likely what's happened is you've encountered a bug in a native C extension to the Ruby interpreter, because it can't differentiate between those. But even that is pretty unusual to hit, because what this person is saying to me is that they're struggling to run the website. And the website is a static site. Middleman is a static site generator. It has one compile step. When you start it up, it takes all of the source files for the website, bundles them up, and then it just starts an HTTP file server. And this was working for a while and then crashing after half an hour, despite the fact that everything should just have happened at the start. So that's the first thing that's strange. The first thing that I did to try and get to the bottom of this was to see if I could reproduce it, because that way I could hopefully come up with a fix, or at least a workaround to give to the person who was being blocked on this. And I could investigate myself without needing to say, hey, can you try this? Can you try this? Which is a bit of a nightmare for everybody involved. So I managed to reproduce it, and here I have the command that I used to reproduce this crash. AB is a program from the Apache Bench package, and it comes built into macOS. And what this command is doing is making 1,000 requests to the local web server and doing 10 of those at a time. Apache Bench is designed for sort of testing websites under load. It gives you kind of nice average response times and deviations and things. But it's also very handy for just making a web server do lots of stuff at once to see what happens. And that's what I did in this case. And this reliably crashed the web server. And it only crashed it when I had this 10 simultaneous thing. If I made 1,000 requests one after the other, or even if I made 10,000 requests one after the other, then it would be fine. So something was going wrong when it was handling multiple requests at the same time. Oh no. I also was curious what was going on here that made it not work for this person, but everybody else who was working on the website could use it fine. And through talking to her and the other people, we figured out that the difference was that most other people were using Ruby version 2.3.7 to run the website, and this person was using Ruby 2.5, which was the latest at the time. So I was able to tell her, well, okay, if you just switch to 2.3.7, which is what everybody else is doing, you can get on with what you're doing, and I can look into this. We don't just want to stay on 2.3.7 forever. So this isn't a good long-term fix, but it at least lets everybody else keep moving for now. Ruby 2.3 has security maintenance up until the 29th of March this year. So really, we want to, figuring this out is fairly important for us because we want to upgrade, but we don't want to upgrade to a version of Ruby that crashes at random. So I continued working away at this, but I didn't really have any leads. I didn't know where to go from here because all I knew was if I make lots of requests at the same time, it crashes. I knew that it was unlikely to be a problem in our code because it was crashing in a C extension somewhere or in Ruby itself. And we don't have any C extensions in the code base for our website, which is something that I'm extremely thankful for. I don't want to see the future where that is not the case. So I did the only thing that I could do, knowing that this was something that we really needed to get to the bottom of. And so I had to do something. And so I just started, I made the sort of simplest hello world middleman site and confirmed that I couldn't reproduce the problem on that. So there was something in between that and our very big website that was causing this crash to happen. And so, okay, let's try and narrow down what the difference between these is. And so I started deleting code from our website. One file, one directory, one line at a time, until I was left with a very, very simple small amount of code that could reproduce the problem. This took a long time, and it was very dull. But it was something that I could do. And anything kind of more complicated than this would probably have taken me even more time to figure out what to do, learn how to do it, and so on. And so I eventually narrowed it down to this. This is some Ruby code that was that we were using as like a plugin for Middleman, so that our page templates could get the dimensions of an image. Now the actual plugin that we were using was much more complicated than this, but I deleted all the bits that didn't seem to make a difference until I was just left with this. And all this is doing is it's a method that takes a URL parameter And then it just passes that through to a library called FastImage with some slight modification to the parameter. So what's FastImage? I'd never heard of it. Apparently, it finds the size or type of an image given its URI by fetching as little as needed. What that means is that rather than reading a 2 megabyte image into memory, it will read the first few bytes, which is enough to tell the width and height of the image, and if it's a JPEG or a PNG, or the other format whose name I won't say for fear of repercussions. Okay. Well, maybe this could be our culprit. Maybe FastImage is a C extension that's causing the problem because it's not going to be a bug in the interpreter. And so I looked at FastImage's code. There was no C extension there. FastImage is a pure Ruby library. So that's not a good sign. But, you know, whatever. And no. So, I have this library, and it seems like it's probably the problem. I'm still, to test this, I'm still having to start up my web server, compile the website, make my lots and lots of requests, hope that it crashes at some point after some number of requests. It wasn't a consistent number that it took to crash it. So maybe I can eliminate some of that, because that's still a lot of code that I'm working with. Maybe I can eliminate the web server part of it. And as it turns out, I could just write a little Ruby script that started up 500 threads at the same time and got them all to ask FastImage for the size of an image all at once, and this triggered the same crash. So that's good. We've eliminated the static site generator. We've eliminated the web server. Our problem is somewhere in this very small amount of code. But that small amount of code still isn't everything, because we have the Ruby interpreter and we have this FastImage library still at play. The simplest next step is to see if we can kind of simplify this even more and get rid of FastImage. Because FastImage is pure Ruby. It must be doing something in Ruby that is causing the interpreter to crash. We're fairly confident at this point that it's an actual interpreter bug. But we have no idea what that could be. So I go to my last resort strategy again, and I get the FastImage code, and I delete bits of it, one method at a time, one line at a time, until I have the one line of Ruby code that actually causes the problem, and now I don't need to consider the rest of FastImage anymore. And this is what I'm left with. Now, this was not a script that I wrote for readability, so I'll explain what this does. It starts 200 threads. In each of those threads, it starts a fiber. I'm guessing not many people know what a fiber is. Is that assumption correct? Yeah? Okay. So a fiber is in other programming languages, similar concepts are referred to as generators or coroutines. And a fiber is a block of code that you can run for a little bit, and then it'll stop, and you can start it running again. You can stop it, and it's like a thread, except that it runs in the same thread as all the code surrounding it, which is a bit of a tricky concept, and it's difficult to see how this could be useful. But it's actually very, very useful when you want to, say, have a loop, but from other code, you just want to run bits of that loop at a time. For example, FastImage has a loop where it reads in some number of bytes at a time into a buffer. And it doesn't want to read any more than necessary, but some other code outside of the loop can be extracted that can say, okay, loop, do the next bit, but you just write that as a loop and don't have to think about it being sort of paused halfway through. So this fiber starts, it opens the file containing, it opens its own file, the file containing this script. It reads 1 byte, and then it returns it to the process that to the code that ran the fiber. That's what the fiber.yield does. And .resume there just tells the fiber to run until it next yields, and then it gets the value back that was yielded. And in this case, we just ignore that value. So it does that 200 times all at the same time, and then it does that whole process 500 times, because doing this didn't consistently crash until I did it that much. It's sort of, there was a low probability that it would crash, but if I did it enough, it would crash. That probability would go to 100%, and this would crash every time. And I played around with this a bit more. I tried, well, maybe it's something to do with opening and reading from a file. And I tried changing that. I tried making it so the fiber just yielded hello world. And that still crashed sometimes. So I knew it wasn't actually a problem with doing file I/O. It just, having the file I/O seemed to make it happen more for whatever reason. It hit the right code paths more often. It took long enough. Whatever, I don't know. So this was pretty good. This was pretty good to reproduce the bug, prove that it was an interpreter bug, because we're not loading any libraries here. This is all just stuff that comes with Ruby. And now I could try and figure out why this was happening. And I think it's important to note here that I am not a Ruby interpreter developer. I've looked at the source on occasion to figure out how something works. I don't know how most of it works. I certainly don't understand the kind of guts of it. But that's okay, because I didn't need to. Because I had my friend Git bisect. Git bisect is a feature of Git that lets you say, okay, at this point in history, the software was good. At this point in history, sometime later, the software got bad. And it will then do a binary search, checking the version in the middle of those two, then the middle of what's left, and so on, until after maybe 10 iterations, it has figured out what the very first version that was bad was. And how does it know what's bad? Well, we tell it how to find out what's bad. And that's what this last line does. It just compiles a version of Ruby at that point in time, runs my test script, and sees if it crashes. And this ran for a while. This took quite a few hours, because compiling Ruby isn't a particularly quick process. But again, it was quicker to do it this way than to try and, you know, like getting acquainted with the actual code here would have taken me months. So it was much quicker to just sort of sit and stare at my computer all day while it figured it out for me. And we got a result, and it was this. This was the first bad revision. The revision here is numbered, just as a probably not very interesting technicality, rather than being a hash like git commits usually are, because Ruby's canonical source control repository is Subversion. And so I've given the Subversion numbers here, even though I was using it through Git, because that's what I know. So because these are kind of the canonical identifiers of the change. So this is a change to some C code in the Ruby interpreter, and it changes the value of a constant from 0 to 1. The name of the constant is useThreadCache, and this is where our crash was introduced. So I don't know what a thread cache is, but I know that it's likely causing the problem, and that's good. As it turns out, I didn't have to know what a thread cache was to identify that this was my problem. But this still isn't a great answer, because presumably the reason they've turned on a thread cache and the reason they have a thread cache at all is that there's some benefit to it. And so I probably don't want to just report a bug and say, hey, you should disable the thread cache because it's bad and broken. This actually isn't very helpful in that sense. So maybe we can do better. And maybe we can do better still not having to understand how the Ruby interpreter works and letting the computer figure it out for us. So what if, for example, I did the same thing again, except that before I compiled the version of Ruby at whatever point in time we were testing, I changed this 0 to a 1 myself, so that I was always using the thread cache. And maybe that way we would actually see why, like the thread cache changing over time and finding a point where this bug was introduced. For that to work, we have to assume that the thread cache, whatever it is, was not initially buggy. But we can test that by just going back to some point in time a while ago and checking manually if we can reproduce the problem with the thread cache on at that point in time. And so I waited another day or so, let my computer test lots of versions of Ruby, this time always with the thread cache enabled, and I got to revision 60,440. And the commit message here is use RB execution context T instead of RB thread T to represent execution context. I don't know what that means. But if we look at the diff, which I have not included here, I thought I had, we don't need to look at, I didn't include the diff because the diff was very long. And I could see, okay, there's some code here that's moving around, there's things being added, things being removed. This is a refactor. This is far more likely to be the actual place that our bug was introduced than changing a 0 to a 1. So that gives us enough information to actually file a bug report. And this is the start of my bug report. I just included everything I knew. I tested this on macOS and on Solaris, and it crashed on those, didn't crash on Linux. I know that it was introduced by this particular change, so just something in this, couple of hundred lines of changes is what you're looking for to figure this out. And I was able to provide this really quite detailed bug report despite knowing basically nothing about the code that I was talking about. And so hopefully that was going to be very helpful to whoever came and looked at this and was familiar with the code and was going to be able to figure out what had actually gone wrong and make a fix. And then this was the response I got a few months later when somebody actually came across my bug. By the time they came across the bug, it had been fixed. So my lovely reporting and investigation was ultimately not super useful, but there was no way for me to have known that. And it was still a very useful thing to kind of go through, know how to do, and be able to talk about. So I checked, and yep, Ruby 2.6, which came out shortly after this, had the bug fixed. It had some other bugs. So we're still not running it. We still have a month and a half, so that's okay. And I have fixed 2 bugs in Ruby since 2.6 came out by following similar processes. And the final thing I want to say is that if this kind of stuff sounds interesting to you, working on these kind of tools that are used very widely across tech stuff, and other tools that are used by fewer people, or if you're interested in managing a very large amount of computers, but computers that only have to work between kind of 9 and 5, so you can go home if they're not working at the end of the day, and get kind of the best of both worlds there. Or if you just want to work with a bunch of really nice people and be the person whose job it is to kind of step in when something's going wrong for somebody and say, hey, I can take a look at this, I can help. You go back and get on with whatever you were doing, and I'll get back to you when we know what's happening. Then you should consider joining my team at Free Agent. You can talk to me about that if you're interested, or look at our website. If you're not interested in this stuff and are just interested in sort of product development jobs as usual, then those are available too. And finally, the slides for this talk are available on GitHub. Both the markdown source file that I used to write the slides and the actual generated presentation that I'm showing to you now. They are available under a Creative Commons license, so you can use bits of them in other stuff for passing on to other people. And they include very, very detailed speaker notes that I wrote mostly so that somebody who was looking at just the slides rather than watching the presentation could still follow what was going on. So if you want to, if something maybe kind of went over your head a bit and you want to read over it again, or see a more sort of thought out explanation of something than the one I'm making up on the spot because I don't have my notes here today, you can check those out. You're welcome to email me about if you just think this stuff is interesting and want to chat about it, or if you want to talk about working at Free Agent or whatever, you can email me. And my OpenPGP public key fingerprint is at the bottom there, which will be of interest to the people who know what that is. And if you don't know what it is, you can ignore that. So that's my talk. That's the story of how I tracked down a bug in the Ruby interpreter without knowing anything about how the Ruby interpreter works. And that's all I have for you. Looks like no, so this is kind of a moot point.
Okay then, we will do introductions and a couple of announcements. First announcement at this point in the day is the usual begging announcement for more speakers, please. If you do something interesting at work or not at work, if you do something interesting to do with tech or have something that you think might be relevant to the people in the room, come and tell us about it. Come and say, I would like to do a talk. Because otherwise, what we have is beer, pizza, and nothing interesting up there. We need your help. Tech Talk needs your help. You can be superheroes.
Okay, what we'll do is we'll just basically pass the mic around the room. People can stand up, introduce themselves, say a little bit about what they do. And then we've got more beer, and then after about 10 minutes of that, we've got a second talk, which is all about software-defined radio and the power of prayer, apparently. Justin. I work for a company called QueryClick, who do a variety of web analytics. As I say, we've got jobs. If anyone's looking for a job in web analytics, by all means, come and talk to me afterwards.
Hi, everybody. I'm Kris. I work for the EPCC, which for some weird reason used to be called the Edinburgh Pal Computing Centre. I think we do something with high performance computers, but we'll leave it at that. Anyway.
Hi everyone, I'm Alyssa. Yeah, I'm a software engineer at a company called FreeAgent. Also, something that I didn't mention, because it was not relevant to my talk, is that I work on a Linux distribution called NixOS. And if you're interested in that, or anything that I mentioned in my talk, come and talk to me.
Hello. My name is Shell. I'm a tech hobbyist type. I'm working on a project which makes DNS easy
Okay, folks, if you'd like to take a seat again. I'll hand you over to Kris, who's going to tell us about software-defined radio.
Thank you. So yeah, wait for everybody to sit down. So yeah, let's talk about software-defined radio. So as I say, I'm Kris Findlay. I've been in IT support for a long time, which kind of came about in a weird way. It was more of a computers are my hobby, and then someone went, "Do you want a job doing that?" I went, "Okay, why not?" Yeah, big mistake, don't do it. I'm working for the EPCC at the moment in high performance computing. I don't know why it's high performance, because basically it's just parallel stuff, isn't it? Lots of things running at the same time. It's like, well, okay, that's not high performance, but anyway. Anyway, using Linux for a while. So, what I want to tell you about is what is software-defined radio, what it's about, a little bit of history, what you can find out about how to get started in it, what hardware you can get, and lots of antennas, which is weird. There's lots of software available for Linux, Windows, and Android. There may be iPhone stuff, but I've not even looked at that. So basically, what is software-defined radio? So, well, as I say, software radio is a communication system where components traditionally implemented hardware. So, did anybody remember the old 56K modems? When they first came out, it was all hardware, they were expensive, really hard to get hold of. And they went, great, we've got these new ones. They're cheap, they're brilliant, you can use them. Only on Windows. Because there's software, and the software only runs on Windows. So, trying to get a Linux machine on the internet was, well, difficult to say the least. Which is interesting here though, but one of the first things that became software defined was, 56K modems and things like that. Nowadays there's loads of stuff to talk about software defined, isn't it? Like networks and everything else, and USB and whatnot. Mainly because it's cheaper. Why do the hard stuff in hardware, do it in software, then you can do more with it? Mainly because the hardware itself, as I say, was expensive. Licensing for this hardware was expensive. People wanted proprietary chips, and you had to buy this chip from this one company, or this other company didn't do it, or some little thing. So reducing hardware was the big thing. 2012 was about the first time where digital TV became cheaper. You could buy a cheap dongle for 20 quid. Later on, and because we got to 2013, people started making open source hardware that you could do software-defined radio stuff with. And as I say, lots of other things started to become more software-defined from a hardware point of view. So basically what we're talking about is radio signals here. And there's lots of different radio signals covering lots of different ranges, from 0 to 1 gigahertz, where there's sort of general radio stuff, like your light switches, your car alarm system is on 433 megahertz. Further up the chain, you've got like GSM, decked phones, like your phone in the house. Although deck's not around as much these days, is it? GPS, that was quite good. Sort of 5 gigahertz range is now Wi-Fi now, but it wasn't for a long time. It was mostly control systems for commercial systems, things like that. 433 and 868 is an interesting set of bands. They're the unlicensed band. You don't have to have a license to operate radio frequencies in that band. So you find a lot of doorbells. What else is that? Z-Wave is a big thing with that, which basically for operating like wireless plugs and things like that, you can turn them on and off. More recently, in the last few years, you've got things like LoRa, which is more of a long range stuff, so it's like 10 radio frequencies, So if you try and send a Wi-Fi signal 10 kilometers, you're not going to get very far. You're lucky if you get, outside your house. LoRa, Sigfox, unfortunately they're both proprietary signals, but they let you send data 15 kilometers. So you can have like a temperature sensor in the middle of a field and somewhere and read that data back over the internet. I had a bigger point to that, I forgot what it was. That's all great. Oh no, it's only 20 baud. We're back to 56k modems again. How did that happen? GSM are trying to bring out their own version of it called Cat5, which is going to be, again, 20 baud. What's going back? I don't go backwards here, you know. But that's not really what we're talking about today. What I really want to talk about is how you can use cheap hardware, 20 quid, actually £6 from China. And you basically buy, which actually is a digital TV dongle. Wearing on a cheap antenna, be it something like this wee extendable thing, or more complicated ones, and receive those signals from all these different protocols and all these different areas and things, and play about with the information available, you know. So the hardware I'm talking about really is one of these little dongles, which is actually a TV dongle. It's supposed to be refusing digital TV, radio, digital radio, stuff like that. There are different chipsets, different types. That's a few of them. The one you'll find more common is the RTL 2382U and the R220T, the most commonly used ones. A lot of them are no longer around anymore or too proprietary. But as I say, it's just this stupid little USB dongle, plugs into your computer. The hardware in it doesn't do anything really, it just receives a signal. And that's pretty much it. But you bet DVD software like DVD Link or something like that, and that'll pull in your TV, and you can sit and watch your TV in your flat or on the road or in the trains. Actually, interesting enough, just last year, company Sony, mainly because some British guy down in Wales wanted to, they'd released a digital video hat, plugs onto the Raspberry Pi for 20 quid. And he assures me he's tested it and you can receive standard definition telly at 60 mile an hour. You have to slow down to 40 to get HD. That's the way it goes, isn't it? But with one of these dongles, as I say, you can scan the network bandwidth. So you can take a Raspberry Pi, plug your screen on it, plug on that, and you can wander around and see all the radio signals traveling back the world, wherever you wander about, which is great. I will come to why that's interesting in a bit. And as I say, that's using a wee 20-chip dongle. There are other things out there because that only allows you to receive data. You can't send any information. You can't send signals to anybody. You can't communicate back and forth. You can just receive the data. In 2013, this open hardware came out called HackRF, slowly followed by Blade RF, and there was a lot of commercial SDRs. With those, you can transmit, but only in the outside of 433 and 868 if you've got a license. So you have to go and get a ham radio license. The interesting thing about ham radio licenses, this comes back to the CB radios, where everybody's sitting in their trucks and their cars and chatting back, you know. Giving a 10-4 and all this, and I don't know, something like Smokey and the Bandit, I don't know. But anyway, with the HackRF and the Blade RF, you can transmit in these systems. But you're talking about £200 for either one of those units. And then the other commercial units above that, you're talking £2,000. That's what HackRF looks like. Slight bit bigger than the dongle. That weird gold bit, there's actually a metal shield across that to keep the RF frequencies out. They've taken that away for some reason. And it actually uses an ARM Cortex chip, which is interesting. What's weird about all this thing though is antennas are the key. You've got to plug an antenna in, and antennas are weird. They've got different lengths and different shapes, and that's important depending on the signal you want to receive. So you get one normal dipole that goes up and down. Usually if you buy a TV dongle or something like that, like this, comes with one of these. They're terrible. Don't get any signal very well. Really crap. For a while, you remember you used to the old TVs, had what they call rabbit ears. So you had two of those, pointed in different directions to try and get more signal. Yeah, there's still not much these days. Which is kind of what the dipole is about. So you've got two of them, going opposite directions. I suppose we get a better signal. Depends what you're going for. This one's more of a DIY. It's ADSB aerial, which is tuned to 10,090 megahertz. There's a good reason for that. Interesting enough, this one's built out of coax cable, joined together and put inside a tube from like B&Q. Cost you about £5. Try and buy one, they'll cost you about 200 quid. Weird. That's an even more complicated one. Again, bit DIY. I'm actually not sure what that's used for, but anyway. I just thought it looked cool. I mean, yeah. Yeah, go for it. Cool. So if you're watching home, yeah, rotational signals for satellites. Makes sense. Yeah, works. Slightly different version, although I believe this one was more used for trying to get signals off of boats. Similar stuff to ADSB for planes, but for boats. But why not? Slightly more DIY that one, isn't it? And I always think these look weird. Disco and lots of things. I don't know if they're trying to make a TP or just got lost, I don't know. Dog seems interested. But anyway, yeah, lots of different aerials, lots of different shapes, all tuned to different signals for different frequencies and things like that. But there's lots of different software available to deal with these. I think I've got more listed for Linux than anything else, but that's just me. Jane Radio is pretty cool. It's really complicated though, but it's good fun. The protocol, these RTL dongles that you find, they use this RTL SDR software, and that does the the transmission of the signal back into software, and then you translate to these other programs like SDR Sharp and AirPro. Wireshark, traditionally known for hacking Wi-Fi networks, it'll do GSM as well. And the base GSM protocol was hacked a long time ago. So was Wi-Fi. So they decided to encrypt it. That was what, 93? Do you know what's weird? It's about the only one they've encrypted. DAB radio you can get. And Windows got similar stuff. Actually, SDR Sharp and Virtual Radar both run under Linux, under Mono. If you use Mono though, I'm not sure why. And of course for Android you can get SDR Touch and Wave Science. Although they're quite expensive, they're almost at £10 each. But the point I was trying to make though, as I say, we've got software radio, what's it good for? And there's lots of things you can do with it. You can scan lots of different radio frequencies. So you can decode ADSB traffic. Now ADSB traffic is a system employed by the aircraft to say, hey, here I am. I'm at this height. I'm traveling at this speed at this GPS location, and here's my ID number. What? It's not scary at all, no. The thing is, it's broadcasting pretty much it's encoded, but it's just broadcast straight. You can go and grab that from anywhere. So if we weren't sitting in a concrete building, we could literally think all the planes going past and get the data directly from the planes, put them on a map and see where they are. I said GSM's been cracked, we can take part of that. POSAG's an interesting one, right? So, pagers. Who had any more hands up? Who had a pager? We've got one guy had a pager. Two. We've got over 2, 3. All right, great. Yeah, they never really took off in Britain anyway, did they? You know, if you tried, get a page, brilliant. You tried to find a phone box. Yeah, that's a bit of a problem. But they're still heavily used within the ambulance service, with the police, and with fire services and things like that. The interesting thing about that is it's not illegal to read the messages. You can look at them, you can do that. You can see the messages, which are, interestingly, with this whole GDPR thing about, have shed loads of personal identifiable information. The messages come up saying that Mrs. Robertson's had a fall. She's at this address. Her phone number's this. Can you send the doctor around? And that's being broadcast in plain text. Well, not plain text, but it's encoded, but you can decode it in like 2 seconds. It's not encrypted. Big difference. And the law states you can read this, you're not allowed to tell anyone what you've read, and you're not allowed to use it in a crime. Well, I don't know about you, but if I was committing a crime, that's... So as I said, ambulance service communications, they're still using these pager messages. I really like this idea of being able to download stuff direct from things. Not going through some third party who might have modified it or something, You can download... Okay, it takes a bit of a weird aerial, and don't get me wrong, it's a bizarre one to build. Probably takes at least a weekend. But you can download at certain times of the day, the weather images directly from the weather satellite. I think that's pretty cool. What you're going to do with them, I don't know, but it still looks pretty cool. That is true. How many people are often on a boat? Just yourself. All right. I'm just thinking, though, it wouldn't be any useful if you were on a sub, would it? You'd be just like, yeah. I think there's a lot of Columbians with subs, but that's another story, yeah. Anybody launched a high altitude balloon? No? School project? Trapped a Raspberry Pi, wee camera, set it up, got pictures of the chronosphere? No? Oh, well, if you do, you can track it with a radio signal. It's brilliant. Anybody got like wireless sensors in the house with temperature sensors, or or have you got a radio system for your boiler? Well, they're on 433 megahertz. You can grab the data off them out there. They're not encrypted. Why you'd want to know your neighbour's got his room set at 30 degrees, I'm not sure, but actually, the last few years, the big thing's been these CubeSats. Everyone's obsessed with, look, you can build a satellite that's tiny. It's like a wee cube, like a mobile phone or something, and just throw it up into the lower atmosphere. It'll just take like 6 months to fall down. Interestingly enough, all the data they're transmitting, all the scientific data, all the tensors, all the sensors, everything they're in, it's all being broadcast in the public. There's no encryption on it. It's a little harder to get because they're floating around quite quickly around the planet. So to get access to these, an open source group based on a Hackaday project at one point went, wait a minute, let's build a network. So they designed, basically using these TV dongles, a satellite dish with one of these dongles in it and a wee motorized system to adjust its power, and they've built a network of these right across the globe. You can book time on these things and go, I want to see this satellite, and I want to go right on it. It's brilliant. Let me repeat myself. So, I suppose if you buy enough of them, you could do some radio astronomy. Unfortunately, you probably need a field probably about twice the size of this room. But it is possible. Why am I getting... That's what I want. You can... Well, monitor meter showers. I'm not entirely sure how that all works, but I've not tried that myself. But I believe they generate some sort of weird frequencies that enter the atmosphere and things. But you can see multimeters. That's quite good. Yeah, that's weird. Oh, actually, you can actually get digital TV. Did I tell you that? That's brilliant. Yeah, digital radio channels and everything. You know. Has anyone actually used that whole like the radio thing where it tells you here's the news and here's when the traffic's getting bad and what's it called, that DVB or something, DRS, RDS, that's it, yeah. It sort of happened for a thing, didn't it? And you had this button you could hit RDS in your car and it would like randomly interrupt your music and you'd be like, shut up, I'm trying to listen to the music. Anyway. That stopped working. Right, we'll do it that way. See, I saw that, you didn't. Oh well. So, this is the ADVS scanner, kind of the input you get from it. I'd like to do this live, but we don't have enough signal here. So, there's a program called Dump. This was off of a program called Dump 1090. So, you install that, you go run, and it produces this web page grabbed from Google Maps. On the top right here, it shows the signals it's got. So it shows you the plane, its flight number, its squawk, which I think is something to do with a specific radio signal for that plane. It gives you its altitude, its speed, where it's going, and how many messages it's seen, and when it last saw it. You can then take that info, track it against another database, and actually find out where the plane was going from. Admittedly, you can do that same thing, but actually, that is actually how Flight Radar 24 works. They've got lots of people around the globe. You're on flight, yeah, I can see you're on Flight Radar, yeah. But that's exactly what they do. They've got loads of people with these dongles sitting about the world, uploading their data to Flight Radar 24. Unfortunately, the only thing it gets you if you upload it to Flight Radar 24 is a free subscription. There is a program for Windows called Virtual Radar, which is a bit more extensive than the Dump 1080 one. It takes the data from Dump 1080 and plots the paths of the flight paths. Yeah, slightly more data in the call signs. Gives you a picture of the plane, and it sometimes will tell you the model of the plane and where it's travelling to and from. It's interesting. As I said, decoding pager messages. Yeah, you can't see that. That's quite good. Sorry, it's not my image anyway. But when you look at radio signals, they come in. This is SDR Sharp on Windows, but this whole waterfall thing on the right here is generally what you see in most things. So each of these sort of red lines, so remember the yellow are the single strongest. So you kind of get this sort of waterfall effect where you can see the signal travelling up and down, and it makes it easier to pick which signals you want or which frequency. And let's say it changes depending on this. I think I can remember what frequency. Yeah, 163. It depends on where you are. There's a database online you can go to, and it'll tell you all the frequencies used by different areas, by different hospitals, by different things. I'm still trying to figure out why I managed to get pager messages from Birmingham in a flat in Dundee. But that's... you could, all right.
So with pagers, the system works throughout the UK and it doesn't know where you are. So it's just got to broadcast it in the whole of the UK.
Cool. Fair enough. Yeah, it looks like that was from Devon, but we'll get there. But that's it, that's cool. You can see pager messages and stuff and find out where the nearest ambulance is going past, because Mrs. Smith down the road's tripped over the dog. I think the whole weather satellite thing's cool. Being able to pull the weather data, you get, let's say, every radio signal's represented by these peaks and troughs and things. But you get your weather images down the bottom, which are pretty much decoded from the message on the right. It's not that interesting. But you can see the radar. It's like you see the radar picture when you go into the weather stations and stuff. Slightly clearer picture. Why do I always put the places in green in outline? What's green for it? Anyway. So here's some links to some other stuff. RTLSD.org basically gives you loads of tutorials and stuff and where you can find out more info about these, what information you want to get and track. You've got virtual radar there, dumped to 90. And lastly, just don't ask.co.uk. So if you've got any questions, just don't ask. My crap domain, but anyway. That might be a little shorter than planned, but oh well. Anybody got any questions? In this building, you've got to be joking. We'll see. Probably not. I did try and get in some air traffic data earlier, but oh, that's a point. Yeah, I don't know what frequency that's on actually. I don't know, we could find out. No, that's running in the background. You can't see that. For the moment, yeah. Right, where's it? Why am I getting this thing? Can't even get radio 2. What's for that? Pavel, what frequency is your mic at? All right, it could be here a while then. Not your equipment, all right. It is switched on, yeah. Don't seem to be getting much, do you? What did you say? X64. Not great, to be honest. Problem, yeah, it doesn't really work in a big room. No, I don't think we're getting anything. That's right. No, don't think we're going to get that at all. You want to see this? I can't find it. It's not getting anything. Yeah, I've got 864. I put that in, but FM or AM? It'd be FM, wouldn't it? So would I, yeah. Oops. Not early enough, it just isn't having it, is it? No, it's not getting anything. Another time. No, we're having a hardware issue. Doesn't work. Anyway. Any other questions? No? Yeah, Ty. What have I used it so far for? No, I've done the whole weather satellite thing, pulled in the weather data and stuff, watched that. I was sitting in, about 2 years ago, I was living in Dundee, and it was really nice putting the ADS tracker up and just seeing the planes going past and where they're going. And I actually was quite surprised that, okay, I was reasonably up top hill near top of Nine Wells, in the hospital, quite a hill in Dundee, but I was actually able to see the air traffic all the way to just as it came into Edinburgh. Which I thought was really kind of cool. Didn't help you seeing your own flight going past. I mean, but it was interesting to see that, and it's kind of special to see. I've got a setup at home as well that is broke since I brought this today. But I've set up a wee mirror in the living room, and yeah, you can just see a list of the planes that are going overhead, which is quite nice. But I've added in the details, so it's got the locations, where they're going, where they're coming, things like that. You can do the similar thing with boats, which is interesting. So when I was out, my dad used to have a boat, doesn't have anymore, but when he used to have a boat, went out in the boat, and it was within 800 metres, you get the same signal, but from a boat. But for some reason, it only happened, it's only 800 metres or something like that. But it gives you a position so you can see other boats, where they are, where they're coming from. There's an interesting project where there's a guy online has fitted one of these to his quadcopter. Adding a wee bit of overlay, and then as he's flying his drone around, he can get virtual reality points on his screen of where the aircraft are as he's flying around. I thought was pretty cool. What else have we seen done that was really good? I don't know, I think one of the things I think that's worth highlighting is the fact that really what's most important about this, and the fact that it's such cheap hardware and there's more or less hardware coming about, is the fact that nearly 90% of those protocols I mentioned are not encrypted. There's no protection on them. The only reason Wi-Fi's is protected is because some business went, oh wait a minute, someone's cracked our Wi-Fi, we need to sort that. Everything else is just in plain text. It's encoded, everything. And I think, I mean, your entire infrastructure, communication between electricity towers, communication between different services, trains, things, everything else, nearly everything uses radio signals, and none of it's encrypted. So some third party coming along going, right, we want to break down their electricity company, we're going to stop them talking to each other. Fine, we're going to stop all the smart meters talking to each other because we're just flat out the signal. All right, none of the smart meters not now, you know? Stuff like that, you know, and we're vulnerable in that sense, and no one's doing anything about it because, like, oh, it's not an issue. It's just no one's looking at that, you know. Especially, I mean, if I took one of these ones that acts hack RFs that can transmit, and I start transmitting false plane data, saying I was a plane near the airport, round about the land zones at a certain height and all that, they're not going to know any otherwise. You know what I mean? That could cause severe problems, severe trouble, and there's nothing to stop me doing it. No, the police will turn up pretty quick. The police will turn up pretty quick, but what I mean is, in general terms though, there's nothing stopping somebody transmitting and stuff like that, you know? The pirate radio used to go on for long years ago. People used to put a couple of batteries in a backpack putting on the radio and getting the bus and riding the bus around and it took the police days to find them. So anyway, we're getting about 9 o'clock. I think it's time to call it. Cheers.
I have a question. Hello?
Question.
Yes. Yes. Sorry, guys. In 90s in United States, there was kind of messaging system. Like I think the old pagers based on that system that was used for sending the short text messages before the text messaging system in our mobile phones. Yeah.
Yeah.
That system. What I know, that system work on 900 megahertz frequency.
Yeah. So
Is
yeah.
it possible to build kind of device, emulate the, let's say, the kind of node or base to run that old devices?
Yeah, of course you could. Yeah.
Yeah?
No problem at all.
So what I should know, the protocol or?
You need the protocol. Yeah.
Right.
So you'd have to find something that maybe either already sent that data out and you could decode it
Right.
by reverse engineering the signal and the data that was within it.
Yeah, well,
Yeah.
I'm asking because I have
Because you've got your PAM, so your
Newton.
Newton, and you
Yeah,
want to get
and-
your Newton. Yeah, I
and
knew exactly what
Apple
you were talking about.
produced-
Yeah.
Yeah, and Apple produced that kind of messaging card for the Newton.
Yeah, you could do that.
I
Yeah,
was-
definitely.
So it's possible, yeah?
Yeah, definitely.
Right,
Yeah,
okay.
you'd have to reverse engineer the protocol, and
Yeah.
that's been done. I mean, I was saying earlier on, there's this LoRa protocol. Now, LoRaWAN is the top end side of this protocol for doing these long range transmissions. LoRaWAN is open source. It's brilliant. I think that's awesome. We can use LoRaWAN. We can go and use that. No, you can't because the physical hardware is locked down. It's the LoRa PHY, which is the hardware part and the firmware that runs on the hardware, is completely locked down until someone at CC3Con 2 years ago reverse engineered it. There's a
So-
talk online. You can see the entire thing, exactly how it runs, exactly how it formats the protocol.
So for that, I could use kind of open source hardware, yeah?
Yes.
Yeah, all right.
Yeah.
Thanks.
Cool. Blue Bezo, is it?